Hi everyone, thanks for coming to this session. In this presentation, I am Fajri, one of the authors. Will talk about the construction of natural language understanding or NLU benchmark for Indonesian language. This benchmark includes 7 different NLP tasks and are examined by an IndoBERT, the Indonesian version of BERT model that we train in our lab. This is a joint work with Afshin Rahimi from the University of Queensland, Jehan Lau, and Timothy Baldwin from the University of Melbourne. Indonesia is a country in the Southeast Asia region. With population more than 270 million, it makes Indonesia as the fourth most populous nation in the world. Most of people in Indonesia is bilingual, speak their local language and Indonesian. And according to some statistics in the internet, there are roughly 200 million Indonesian speakers today. However, this language is underrepresented in deep learning research for NLP. One of the critical reasons is the scarcity of standardized corpus for a different range of tasks. And in this work, we initiate to tackle this problem by introducing IndoLEM and IndoBERT. Two resources consist of NLP task collection and pre-trained language model that we train in our lab. IndoLEM is a collection of natural language understanding corpus for Indonesian. It consists of seven NLP tasks and 8 sub-datasets. We categorize them into 3 groups. The first one is morphosyntactic, and the second one is semantic, and the last one is discourse-related tasks. In this presentation, we are going to discuss them one by one. Additionally, we also release IndoBERT, a BERT model for Indonesian that we train based on the current best practice and use them to evaluate IndoLEM. Before we talk further about IndoLEM, let's talk a bit about other benchmarks in other languages. The first English benchmark we found is XGlue by Wang et al. 2019, where this XGlue consists of 9 language understanding tasks built on existing public dataset. The second one is SuperGlue. It is a set of 8 tasks that are only diverse in task format, but also includes low resource settings. The SuperGlue offers a more challenging framework than Glue. In other language, we found Chinese Glue for Chinese Mandarin. It consists of 8 tasks, while for Vietnamese, we found Nguyen and Nguyen 2020, where they use 4 tasks such as NER, pause-taking, dependency parsing, and language inference. In IACL 2020, actually, there's also a similar work to us. It is called as IndoNLU. However, the resource collection is for sequence labeling and classification tasks only. In the cross-lingual setting, XGlue was introduced as a benchmark dataset that covers nearly 20 languages, and unlike Glue, XGlue includes language generation tasks such as question and headline generation. Recently, other cross-lingual benchmarks are also introduced, such as XStream and MLQA. However, among these 3 cross-lingual benchmarks, the coverage of Indonesian is very low and the data is limited. Therefore, we initiate to tackle this problem by introducing IndoLEM. IndoLEM stands for Indonesian Language Evaluation Montage, where the acronym LEM is the Indonesian words for Glue. Let's take a look to each task one by one. The first category is morphosyntactic that comprises of 3 tasks. The first task is part of speech taking. Pisodo et al. 2009 was the first Indonesian pause taking where they defined 37 texts with 900K tokens. Their corpus is very noisy, however, because it is automatically constructed by translating English corpus to the Indonesian. Our work is based on Dina Karamani et al. 2014 corpus that is manually annotated with 23 texts. The second task is named entity recognition. Budi et al. 2005 was the first study on named entity recognition for Indonesian, where roughly 2,000 sentences are annotated with 3 classes, such as person, location, and organization. There are 2 publicly available Indonesian NER datasets, which are NER UGM and NER UI, and we include this corpus in IndoLEM collection. The first one is NER UI. It comprises of 2,000 sentences from the University of Indonesia, and the second one is NER UGM from the University of Gajah Mada. The third task is dependency parsing. So research on dependency parsing is pioneered by Kamayani and Purwaryanti 2011 and Green et al. 2012. Again, similar with other tasks, their data is relatively small and not publicly available. In 2013, Universal Dependencies released UD Indo GST, as the first standardized UD corpus for Indonesian. In 2018, UD released the second version that contained 1,000 sentences. Alvina et al. 2019 found that these corpora had annotation errors and had issue with Indonesian morphology, and they proposed a fix for that. And in this work, in IndoLEM, we use UD Indo GST and the corrected version of UD Indo PUD in our corpus collection. The next category is semantic, where we cover two tasks. The first one is sentiment analysis. For sentiment analysis, there has been previous work on Indonesian language. However, finding a standardized sentiment analysis corpus is relatively hard. And for IndoLEM, we merge data from Twitter, from Koto and Rahman in TS 2017, and hotel reviews, and perform binary classification tasks in IndoLEM. The next task is summarization. And to date, IndoSum is the largest Indonesian summarization corpus in news domain, manually constructed from CNN Indonesia and local news portal Kumparan. The summary is generated manually, and they also release Oracle, the extractive label that are automatically generated. Our benchmark IndoLEM use the merged corpus for sentiment analysis and IndoSum for extractive summarization. The last category is discourse with two tasks, namely next tweet prediction and message ordering. Our data is sourced from Twitter, where we crawl 9 million raw tweets from April to May 2020. In the first task, we gather Twitter thread from this pool and design next tweet prediction task. The task is to choose one of the correct answer from 4 possible options, given 2 to 4 tweets as the context or premise. For the second task, we propose a related but more complex task of thread message ordering. We construct the data by shuffling Twitter threads containing 3 to 5 tweets and try to predict the right order. In this snippet, we show the example of next tweet prediction task, where in this sample, given 2 tweets about a YouTuber in Indonesia, and we are going to predict the correct next tweet from 4 possible options. This is the summary of all tasks in IndoLEM. We provide canonical split for train, development, and test, where some of them use 5-fold cross-validation evaluation. For pause tagging, we use accuracy and use the split provided by Kemal and Kurniawan et al. 2018. And for NER, we use entity level F1 over the provided dataset. For UD Indo PUD, we use the corrected version by Alvina et al. 2019. And for summarization corpus, we use IndoSum, the data from Kurniawan and Lovan 2018. For training IndoBERT, we use the Hugging Face framework. And as you can see in the slide, we train the IndoBERT with Wikipedia, news article, and Indonesian web corpus. We train with more than 1 million instances and achieve perplexity similar to English BERT. Now let's take a look to the techniques and model we use to evaluate IndoLEM. Our baseline models are generally by LSTM with Indonesian's fast text embedding. And to benchmark IndoBERT, we also compare against 2 pre-existing BERT models, multilingual BERT and a monolingual BERT for Malay. We expect Malay BERT to provide better representation than multilingual BERT for the Indonesian language. This is because both Malay and Indonesian are mutually intelligible with many lexical similarities, but noticeable differences in grammar, pronunciation, and vocabulary. First, for pause tagging, we employ Lempel et al. 2016 as a baseline, while for dependency parsing, we use several baselines such as by Affine Parser, by Dozat and Manning, Rahman and Purwaryanti, and etc. For BERT fine-tuning, we do directly by adding classification layer for pause tagging and NER, while for dependency parsing, we follow Nguyen and Nguyen 2023, where we simply replace the embedding with BERT output for training by Affine Parser. For sentiment analysis, we also use by LSTM and additionally report naive bias and logistic regressions using byte-pair encoding. For summarization, we borrow results from Kurniawan and Lovan. for models such as HMM and Cheng-Lapata 2016. For training summarization model, with BERT, we follow Liu and Lapata 2019 framework. For next tweet prediction, we concatenate all premise tweets into a single document and use a BioLSTM and FastTech word embeddings to obtain the baseline document encoding. We structure this task as a binary classification where we match the premise with each candidate next tweet. In tweet ordering, we design a hierarchical BioLSTM model, and the first BioLSTM is used to encode a single tweet by averaging all hidden states. We use the second BioLSTM to learn the inter-tweet relationship. For BERT fine-tuning, we use CLS representation for predicting next tweet, and for tweet ordering, we apply Liu and Lapata 2019 trick to design multi-tweet representation. Now let's take a look to the experimental result. For the first category, morphosyntactic, all BERT models perform very similarly over the post-tagging task, well above the BioLSTM baseline. Given that Indonesian and Malay share a large number of words, it is not surprising that Malay BERT performs on par with IndoBERT for post-tagging. On the NER task, both Malay BERT and IndoBERT outperform MBERT, which performs similarly to or slightly above the BioLSTM. Next, we also show that BERT augmentation in dependency parsing improve the performance at their UAS and LAS. We notice in UD-INDO-PUD, MBERT performed the best, better than IndoBERT. Please note that sentences in UD-INDO-PUD are not from Indonesian article, yet translated from different languages. We perform further analysis on UD-INDO-PUD by randomly selecting 100 instances. And we found that 44 out of 100 sentences contains directly borrowing of foreign words that should be translated to Indonesian. Also, 20% of sentences are not natural sentences in Indonesian. Because of this, we argue that multilingual BERT is more suitable to be used for UD-INDO-PUD corpus. For the semantic task, IndoBERT outperforms all other methods for both sentiment analysis and extractive summarization. Lastly, in table 6, in this table, we observe that IndoBERT is once again substantially better than the other models at this cross-coherency modeling. And to assess the difficulty of the NTP task, we randomly select 100 test instances, and one of the authors, a native speaker of Indonesian, manually predicted the next tweet. The human performance in NTP is lower than BERT model. In tweet ordering tasks, we also assess human performance by randomly selecting 100 test instances and found the rank correlation score of 0.961 to be slightly higher than IndoBERT. Finally, this is our primary contribution on this research. First, we released IndoLEM, which is by far the most comprehensive NLP dataset for Indonesian. And second, we released IndoBERT, the monolingual BERT for the Indonesian language. Thank you for your attention. We will create a website, indolem.github.io, for downloading the data. And lastly, please check the paper for other technical details. Thank you for your attention.